Hello, my name is Diana Chan, and I am a chemistry tutor at the Natural Social Science Lab at Miami-Dade Kendall campus. In this video, we'll find the relative abundances of each isotope. In previous examples, we have learned how to solve for the average atomic weight, given or not given. We have learned to solve for the atomic weight of each isotope, whether it is isotope 1, 2, or maybe even 3. And in this video, we will learn how to solve for the relative abundances, or the percent abundances of each isotope. Jumping into the last installment, example 5, bromine with a molar mass of 79.9 grams per mole has two common and stable isotopes, 79 Br and 81 Br. Using our formulas, we can again plug and chug to find out the abundance of both of the isotopes. So again, we're going to go back to the formula from Module 5, and we are just going to plug and chug to find out the abundances for both of the isotopes. So I'm going to write down what's given, and we can just simply plug these into the equation up there. Now, looking at this problem, it kind of seems a little difficult because there are two variables here, F1 and F2. They aren't the same, but we can solve for one of them, reverting back to simple algebra. From algebra, we know that to find the value of the second variable, we need at least another equation. So, we need an equation relating F1 and F2. Aha! We know F1 plus F2 equals 1. So, we can maneuver this so that F2 equals 1 minus F1. And now, we can just plug this into F2. So I'm going to do that right now, where we know that F2 equals 1 minus F1. Now that we only have one variable to solve for, we can again solve it algebraically. You see, I've distributed the 81 to both the 1 and the F1 here to make 81 minus 81 F1. And now, rearranging the formula, I've simply just moved the 81 F1 towards the 79 F1. And I'm going to simplify this, and I'm going to subtract this. We're left with negative 1.1 equals negative 2 F1. So dividing both sides by negative 2, I'm just going to continue over here. We know that negative 1.1 over negative 2 equals F1, or that equals 0.55. Now this, remember, is the equivalent of 55 over 100, or 55%. Knowing F1 now, F1 equals 0.55, we can now solve for F2, again using our formula from Module 5. Over here now, we know that F1 equals 0.55. So plugging that in, 0.55 plus F2 equals 1.0. Solving for F2, F2 equals 45%. So using the formulas from Module 5, we can even solve for the relative abundances of isotopes with seemingly no information given. Well, that is the last installment to the isotopes video series. I hope that they help you and that you see problems similar to that on your exams and homeworks. Thank you for joining me. If you do need any more assistance, please feel free to stop by our lab, the Natural Social Science Lab over here at Miami-Dade Kendall campus in the computer courtyard. Feel free to make an appointment if you need help with any of your chemistry needs. Thank you.